Chapter 5, Section 2, Handling Missing Values. Handling missing values is a major problem in data cleaning. This is not a complicated problem, but there are various methods to perform it. So, I will talk about how to handle missing values by an independent section. Missing data, also called as missing value, is data with no available value. Data can be missing due to several reasons. First, in a questionnaire survey, respondents can unintentionally skip the question as just an oversight. Second, respondents do not answer intentionally because they refuse to provide information about it, or they cannot understand what the question means. Or, respondents think that answering the question is too time-consuming. Third, data entry administrator mistakenly leave the cell blank. As we noted before, rows and columns with many missing values sometimes should be deleted. But as you know, as a basic principle, we should keep the information as much as possible. So, deleting is the last resort that is the least preferred. Other than deleting, we have two options. First, impute the missing data with appropriate value. Second, keep the data and articulate that it is missing data. Specifically, we can input NaN in a cell to indicate that it is a missing value. But many of causal models and prediction models cannot be developed if the dataset contains a missing value. Consequently, we need to drop variables with missing data in developing those models. So, imputation is the most preferred option to handle missing values. Let's see how to impute missing data. In some cases, we can see what values to impute logically or empirically. For instance, in a case of customer data, even if a customer's age is missing, we can impute the right value if we have data of the customer's birthday. So, in this dataset, the age of ID A004 is missing, but we have data of the person's birthday. So, we can identify this person's age from the birthday. When we cannot identify the appropriate value with certainty, as a next best, we can impute missing data with the variable's representative value. If the variable is numerical data, we impute missing data with the mean or median. If the variable is categorical data, we can use the mode. We can see that the data of age and birthday is missing for ID She008. In such a case, we cannot compute the age as we did for ID She004. So, the second best is to impute this missing value with a median. And we can see that the data of country for ID She004 is missing. But country is categorical value, so we cannot compute mean or median. So, in this case, we can use the mode for imputing the missing value. More elaborated way of imputation is using machine learning algorithms. Using other variables as predictor, a machine learning algorithm can estimate the most possible value for the missing data. A popular algorithm used for this purpose is k-nearest neighbor that will be covered in the following chapters. A dataset often contains outliers. An outlier is a data point with an extremely high or extremely low values relative to the nearest and the rest of the data points. So, in some cases, an outlier is a product of human error, such as a mistake in data entry. In such cases, the outlier should be modified or deleted because it will not provide us with accurate information. We can delete and modify outliers using the same methods we use for erroneous entries and missing data. In other cases, an outlier is a legitimate value. For instance, when we collect the citizen's annual income, we often find very few cases with extraordinarily high annual income. If we want to compute the average income as an analysis of local economy, we should keep the outliers as legitimate value. However, if we use the dataset for customer analysis and want to know the general customer segment, we should sometimes delete such outliers because they distort the center and distribution of the data. There is no strict definition for an outlier, but in practice, IQR and empirical rule are used to define and detect outliers. IQR-based definition is the most popularly used, so let's begin an IQR-based definition. In IQR-based definition, observed values that are smaller than 1.5 IQR below the first quartile or larger than 1.5 IQR above the third quartile are regarded as outliers. Remember that an IQR is the difference between the third quartile and the first quartile. So, the lower bound is the first quarter minus 1.5 times IQR. Observed values lower than the lower bound are regarded as outliers. The upper bound is the third quarter plus 1.5 times IQR. Observed values higher than the upper bound are regarded as outliers. If the data is normally distributed, we can also use the empirical rule to define an outlier. Remember the tenet of the empirical rule. If observed values are normally distributed or approximately normally distributed, about 68% of the data fall within one standard deviation of the mean. And about 95% of the data fall within two standard deviations of the mean. And about 99.7% of the data fall within three standard deviations of the mean. Based on the empirical rule, we can define an outlier as data lies outside three standard deviations of the mean. That is, data lies in the red region in the figure can be regarded as outliers. This chart shows how to handle outliers. First, we need to consider, is it an obvious error? For example, a person was born in 3009. It is an obvious mistake because we are in the 21st century. And the person is 345 years old. It is an obvious error because we have not seen such people. These cases are obvious errors, so we go to the left direction. Then, we need to ask ourselves, can we modify the outlier with a value that is correct certainly? In the case of birth year, we can say that it is a typo of 2009. So, we can modify it. But in the case of age is 345, we are not sure whether the correct age is 34, 45, or others. In such a case, we need to carry out additional research to find the correct value. Or, at the last resort, we should delete it so as not to distort the results of our analysis. Let's go back to the first question. In some cases, we cannot say it is an obvious error. For example, as a person's age, 119 is a very rare value, but not impossible. Similarly, 218 cm of body height is rare but possible. In such cases, we need to check the data or carry out additional research to identify the correct value. Then, we should determine whether to keep it as it is, modify, or delete it. Thank you for watching. Please thumbs up and subscribe to my channel.